Dr. In-Jae Chung to actually give us an overview of the future of display industry. And Dr. Chung is he's a physicist like me, okay, but he's also a PhD in electronics engineering from the University of South Australia. He was the head notebook development department and liquid crystal development display lab at LG in 1996. The executive vice president, LG Display Limited since 2006, chief technical officer since 2007, and again brings a tremendous learning to this forum. Dr. Chung, your audience.
Thank you very much for kind introduction to me. I am In-Jae Chung and currently working as a professor in Kyung University. I started my career as 1982 to join the Korea Institute of Science and Technology as a research engineer. And from 1990, I joined the previous LG, is a Gold Star. When we started the LCD business, LCD R&D, I joined the R&D center as a design engineer. So year 2002, I became the head of R&D center, and in 2007, I became the CTO of LG Displays. I'm not the market analyst, but I have a keen note on what the market looks like. So today, I want to give you some brief introduction to global display trend. The topics what I give today is what the flat panel display market looks like, and what is the most efficient panel manufacturing technology in terms of performance, in terms of efficiencies. What we learned from LG Display Gen 8 ecosystem, and how we call him, it's a very successful manufacturing line, what is the success factor, and what will be the future display industries. This is my presentations, or the total contents of my presentations. First, I would like to start with the flat panel display market outlook. It's coming from the IHS data. Starting from year 2000, it's forecast year 2020. At maybe 1998 or 1999, we started the monitor business. Before that, it was just the notebook businesses. So then make the Gen 4, we started the monitor business because at that time, mainly the monitors are CRT, cathode ray tube. It's a very bulky and power-hungry systems. So replace that one with a very flat panel display like LCD with a power-saving models. We can start the business with the LCD. Then it's a business is going up by finding out new applications. From 1990, year 2004 or 5, we start to build the Gen 6. That was the first stage to start the TV business. And the TV business is Gen 6 is around the size-wise, screen size-wise, less than 30 inches. From year 2006 or 7, we built a Gen 7. That is the main lines for TV productions. Currently, Gen 8.5, Gen 8 line is main lines for TV manufacturing. And the flat panel displays market will growing for every year, are expected. Here are some pictures like at the beginning, before year 2002, it started with the notebook applications. And the year 2000, they start the monitor business. And in 2005, the TV business is booming. And nowadays, displays for smartphone is booming as well. So market is every time is growing depending on they find out the new application areas. Once LCD is introduced in the market, then the other displays like cathode ray tube or PDP or even in real projections is fade away. So almost all, nowadays almost all displays are using the LCD technologies. Some people say maybe sooner or later they will OLED will catch up the market, but I don't think it is quite happen in near futures. Maybe Michael, you have a different opinion. So up to now, maybe till the year 2000, LCD will be the main trend in the TV market. The reason why, I've analyzed the reason with the two portions, like what about the performance, how about the manufacturing capabilities. First, I would like to start with the resolution and the screen size. This is the latest one. Maybe the left side, the big one was a UHD TV with a 98 inch in the screen size with the UHD. And it was from the last year, UHD is in the market. So LCD is able to generate such a high PPI display with the existing amorphous silicon technology. Because the people love to see the high definition displays, larger SID displays, because it is gave them more vivid images. And also high resolution can give more information in the one panels. LCD is for the time being the main display technology to cover that high resolution, larger size screen displays. The second one was enhanced color gamut. When the OLED is introduced first in the market, they were very much delighted, emphasis on color gamut. Compared with the LCD, color gamut of OLED is around more than 100%, but LCD at that time was less than 100%. So in order to increase the color gamut, they have some side effects that reduce the brightnesses. So it is moving in the contrary. But nowadays, LCD with some advanced material technology like Q-dot and nanocell technology or advanced LED can possibly generate wide color gamut, even larger than existing OLED technology. That is the current situation. In order to OLED have to have more wide color gamut, higher than 100% to 125, then they need a new material for that purpose. There are some comparisons of performance, LCD versus OLED. I quoted this data from the CNNT, who is comparing the data, making data for which is better, LCD and OLED. So in terms of brightness, LCD is better, but black level, OLED is better. Contrast, as a black level is low, so OLED is better. But if we LCD introduce local dimming lighting technology, then they can greatly increase the contrast ratios. Resolution-wise, LCD is better than OLED. And refresh rate, high dynamic ranges, viewing angle, uniformity, almost the same. The one thing what I want to emphasize is energy consumptions. Energy consumptions on LCD is smaller than OLED. So that is the important point for the future display technologies. So one of the weak points that was mentioned by OLED developers. Now, almost all are overcome by the appropriate technologies. That is the current situations. So I say, hey, in terms of performance, there is no big difference between OLED and LCD in case of larger size displays. Second thing, what I'm trying to say is what about the pre-panel technology evolves in terms of manufacturing efficiencies. Let me start with the substrate size. Nowadays, the substrate is a Gen 8.5 generations. China is currently building Gen 10, but currently the most available equipment and the most efficient, largest equipment for LCD manufacturing is Gen 8.5. So with Gen 8.5, we can make 18 ops of 32 inches or 2 ops of 92 inches. It's depending on the market situations, the design strategies. So from small size to big size, you can use existing infrastructures of TFT LCDs. In case of small OLED display for mobile phone application, the largest size of that is Gen 6, is 1500 by 1850 millimeters. So here, it's limited by the another type of TFT back-plane technologies. So here, within Gen 8 or even Gen 10, currently they are utilizing the already developed amorphous silicon technology for making TFT backplanes. That is the current situation. The other thing what I am trying to say is investment efficiency. We normally, in case of investment, before we investment, what is the investment efficiencies? Investment efficiencies looks like total capacities. Capacities like grass area by capacity per month was divided by the total investment. Total investment that include equipment cost and the building cost and the SID costs. So total investment divided by total capacity per month. Then we call it, that is has some definitions of investment efficiencies. Normally, at the beginning, it's based upon all the memories and all the newspapers. So at the beginning, Gen 6 cases, the investment efficiency was just 11,000 per square meters. And Gen 7, it became $8,500 per square meters. In Gen 8, it became less than $5,000 per square meters. Currently, when I see the newspaper, they announced that they are building Gen 10 or Gen 11.9, but the total investment is higher than Gen 8. It's almost $7,000 or higher than $7,000 per square meters. That is because of they have, in order to make a Gen 10 system, they have to make a new equipment for learnings. So Gen 8.5 is currently most available and the most efficient the manufacturing equipment up to now. This is another data. So with the existing technology, how can you increase the PPIs? But TFT backplane technology, because TFT LCD, TFT technology, amorphous TFT technology fully developed backplane technology and have some competitiveness compared with LTPS. As I mentioned before, LTPS, the glass substrate size is limited on Gen 6. They cannot produce larger size displays like that. But in Gen 8.5, you can generate more than 82 inch, 2 ops of 82 inch displays. So in terms of performance, in terms of manufacturing capabilities, the Gen 8.5 and LCD have a good opportunity to the used in the future directions as well. Here I am to say, what about our previous LG lines? Because at that time I was working as a CTO and analyzed what is the best way to install the Gen 8. So first I would like to say supply chain. Supply chain is including like this, not only display manufacturer, all the material and the chemical component makes are all together in nearby sites. So something has happened, we gave a feedback to them and they gave another feedback to us. So it's a very quick response and get very quick deliveries. So not only the display in the manufacturer itself, we also encourage the companies who supply us material or component, even equipment maintenance. Companies are also joined in nearby sites. This is one of the pictures like that. So it's taken by remote areas. So P7 was the first. The second one is the P8. P8 was here. Now they built the P9, but P9 is the same glass substrate as a P8. One thing, because we need a high energy consumption company, so we need some substations. So government actually built a 154 kilovolt electricity line just nearby. And also, because the river is here, so we need some water. So government made some water pumping line in here. So they supply water here. So we also need some dormitory in here. So this is LG cluster, display cluster. Within that, gas or chemicals are located nearby. And some LG affiliate complex, they supply us LED backlighting, LED lamp or other glass substrates and the polarizers in here, and another areas in here. So all the materials or components are within 5 kilometers ranges. So area actually it's a demilitarized. Do you have heard about the demilitarized zone between South Korea and North Korea? Just by near, just here is the river. Just close that is North Korea. So it's very close. The reason why we take this site as a manufacturing site is because that was very close to North Korea. The land price is very low compared to others. That was the main purpose. Yeah. If you build to China, there is because the China government owned the land, so there is no land price is here. But to building or to have such a big site, land price is very important to us. So here we developed this site because of the strong support from the government in terms of land price, in terms of electricity, or in terms of power, water supplies. So the Paju government actually delivered us these areas, and the population-wise, at the beginning was 300,000 people are living in there. That became 450,000 people are over there, and their tax income was increased more than 3 times than before. So it's a big, and not only for the manufacturing sites, there are dormitories, accommodations, restaurants, all the facilities for hotels, the convenience stores. They are growing up all together. That was one of the good sites for them. Here I can say, hey, what happened in our Gen 8 and the Gen 8 extensions? So compared with the previous one, Gen 6 was our investment efficiency was around $11,000 per square meter. In case of Gen 7, it was $8,500. But in Gen 8, even though the area is decreased, but the price investment was greatly reduced, almost more than 60% of that. So in case of extension, is we reduced the investment, increased the further. So in terms of investment efficiency, currently Gen A was the best, lowest investment efficiency than the others. This picture shows you some of the comparison between existing amorphous silicon technology and the LTPS LCD technology for mobile phone, OLED technology for the TV, compared in Gen 6, it's comparing with amorphous silicon, the investment is almost 4 times larger than the amorphous silicon. So that is the current situation. Here are some, not only to make the eco-friendly the system for the supply chain, we also try to make the environmental friendly, human friendly filter sites like that. So all the used water was chemically treated and also discharged within the company streams. So we call it manucheon. So here discharged water is coming from here. Also we try to reduce any hazard materials in here, so can give us very clean, eco-friendly environment to us. So I say, hey, Gen A, our Gen A factory in the Paju factory still gave us around more than 20% of our revenue, shares 20% of our revenue, and they give us a lot of profit in the TV business. What is the success story? We built the supply chain very nicely, just in time, short lead time, then also give us high quality control. Then application to and technology wise, we have R&D capability, and also we keep on introducing new technology innovation in terms of reduced mask step, and another one is color filter on TFT. So color filter and the TFT originally made and separately and put together to make colors. But here we introduced a new technology like color filter is on the transistor arrays. So that is another technology that greatly increased the power efficiency of LCD displays. Investment, tiny investment, and efficient investment is needed. So once we started to mass production of Gen 8, then we built another line, Gen 8 Extend. And the third line, Gen 8 Extend Plus. So at the beginning, built the factory first, building first. Then, because it takes 1.5 years or 2 years to building the clean rooms. So normally we build the clean room first, then think about what the market looks like. How does it move? So people like to see the larger screen size display, then we changed the generation, substrate sizes in here. That was the main stories like that. So, and the sustainability, once we built the factory, then the next thing what we are very much focused on is how we improve the capacity and the minimizing by loss. We call it max cap and min loss. So once we install the line, then try to utilize the manufacturing line as possible, as high as possible. Then reduce the loss. That is in turn the yield. So keep on yield. Still the LCD display case, the yield is more than 94 or 5%. So it's a very big differences from the other companies. Okay, still flat panel display technology for TV is increasing. Here they say the red color and the blue color is actually LED, LCD, or LCD, but there is no big difference between that. So this is more than 60 to 70% are covering by LCD technology till 2022. Maybe the green line show you some of the OLED portions, but not only TV, also smartphone use the OLED displays. That is incorporated, accounted in here. So portions are less than around 20 or 25%. Why, asking me why you say the flat panel display industry is growing? There are some explanations like that. People like to see bigger size, bigger screen size displays. So starting from 32, now is almost 42 or 43 inches. It increased 1 inch per every year. So maybe year 2020, people like to see the bigger one. So that is one of the reasons why I'm still saying the market is growing. The other one is there are several number of new applications. So at all the times, displays are very expensive component, but nowadays it's very cheap. So using the displays, they can make a lot of touch screen or whiteboard depending on their applications. So previous notebook, monitor, TV was the three main application areas, but nowadays the application areas are widening and deeper. So that makes the display industry is more still growing for every year. This is another example, so what I quoted is, in case of a car, there are so many displays in the rear seat, clusters or mirrors. There are so many cars use the displays in here. Still, people say worry about what about OLED? So these pictures are made by IHS, display research company, and I use the data to comparing the capacities. So the capacity of LCD is around here. I summed everything and it's 310 million square meters. But year 2019, based on all the informations that the company tried to build, is still the capacity-wise is 30 square meters, almost 1/10 of the LCD capacities. That is the year 2019 situations. The other thing is manufacturing costs. Before I came here, I asked to the leader who is developing OLED TV for commercial usage, and compared the data with the LCD. So it's still, the price-wise is 2.5 times expensive than LCD. Almost the expensive is come from the depreciation costs. So depreciation cost means the evaporating the thin film on top of the TFT array. That equipment is expensive as well. And also the capacity-wise, their capacity-wise is very limited because of the low yields. So that is a big differences. So you can have a manufacturing cost is much more efficient in using LCD. So in summary, I say flat panel market, healthy growth. And the Gen 8.5, well-developed manufacturing line, and also well-developed manufacturing line in terms of efficiencies. Give us best return on investment. And the display manufacturing needs some learning experience. OLED cases need more R&D and lead time for mass productions. For the time being, the OLED is used for smartphone. In that case, it's very much successful. but make a big size screen, big screen TV, still a lot of challenges out there. The timely investment is key for the display business. Thank you for your attention.